Hey guys, welcome back to another exciting video on math for 4th grade at Aspen Country Day. I am so glad to be doing another video for you guys. We're getting down to the wire, so we really are trying to push through and get a lot of work done in before the end of the year. So I appreciate you hanging in there with me. For today, we're going to start out with some supplies, and then we're going to do a warm-up problem on 2 by 2 multiplication, since I've been getting a lot of questions about that. So I wanted to go over some of that. So let's grab our supplies. We're going to need a pencil, your notebook, and then for today you have your student book. No home connections today. So let's go ahead and grab that stuff and then meet me back here. All right, go. All right, so now that you have your stuff, let's go ahead and open up your notebooks. Let's grab a pencil, and today we're going to go over 2 by 2 multiplication. It's shown up in some of your student book and some of your home connections pages, and I've been getting some questions about it, so I wanted to go over it with you one more time. It's also, because we have learned to do this using the area model, it'll also help us reinforce how to find the area of a shape. So I wanted to do that today. So let's go ahead and open up a page and let's get started. All right, so I'm gonna set up my problem going right across the top of my page here. And I want you to follow along in your notebook. I know some of us have already learned this method, but again, I'm getting a lot of questions on it. So I want to make sure we all have a good refresher. So let's go ahead and start out by setting up our equation as 29 times 56. All right. The way that we have used the area model in the past is that we have set up a four-sided shape like this. Just want to make sure we have everything in there. And what I have done is that I have divided this into 4 different sections. I've turned this into fourths, okay? The second thing that I've done is that I've taken my 2-digit numbers and I have broken them up by place value. And then I've placed them each on each side, the top and then the right-hand side here, okay? So for example, this 29, I have broken this up as a 2 in the tens, which gives me 20. And then 9 here. And at the top, and it doesn't matter which order they go in with multiplication, the order of the number doesn't matter. But what does matter is that we have the number 20 and 9, or 29, on one side. We don't want to put 20 here and then 9 here, for example, okay? The second number, 56, gets broken up as 50 and 6, or 5 in the tens and 6 in the ones. So we start this as 50 and 6. So hopefully this starts looking a little familiar, okay? We know that when we take the area of a shape, for example, like this rectangle that we have to multiply each of the sides, the length times the width, to find the area. So that's exactly what we're going to do in here, okay? So I want you to think of each of these squares as different equations. For example, this first one here will be 50 times 20, because those are the 2 sides here. In this next square, we'll have to multiply 20 from here and the 6 at the top. The bottom ones here, we'll get to multiply 50 times 9 in this first one here, because the area of this would be the 9 here and the 50 from the top. And then finally, our last equation in this fourth box will be 6 times 9. All right? So now that we have that, we have to go ahead and multiply each of these numbers together to get our answers. So for this first one, it's 50 times 20. And this one, we can simplify it by first just covering up those zeros at the end of each number and be left with 5 times 2, which gives us 10. And then I'm going to add the 2 zeros, the one after the 5 and 50, and the one after the 2 and 20. So I'm going to add 2 more zeros to that. So this first box here is going to give me 1,000. The next one down below, I'm going to do that same strategy of erasing one of the the 0 here. So I'm going to block that out, and I'm left with 5 times 9. 5 times 9 gives me 45. And I'm going to bring back this 0 here and to get 450. I'm going to do that with every single box here. So this 20 times 6 is really, I'm going to think of it as 2 times 6, which gives me 12. And then I'm going to add the 0 here after the 2 and 20 to get 120. And then finally, I have to multiply 6 times 9. Okay? 6 times 9 gives me 54. And so our last step is to take each one of the answers from our equations here, or each of the areas, and add them together. So on the right-hand side here, I'm going to do this from biggest to smallest, and I'm going to make sure that I line them up by place value. So I have 1,000, and then my next number here is 450, followed by 120, followed by 54. Okay? I'm going to add all of these up, so I'm going to get 1,624 as my final answer for 29 times 56. This is going to equal 1,624. Okay? Now, in your notebooks, using the same model, I want you to find the answer to this multiplication problem, and I'll move it up in just a little bit. We have 36 times 72, okay? 46 times 72. I want you in your notebooks to show me what the answer of this is by using this area model, okay? So you're gonna build your squares, and then you are going to take the area of each one of those squares in there, okay? You don't need to write down these equations in there, especially if you know what numbers you're multiplying in. But if it helps you, I want you to go ahead and write down each of the equations, okay? Let's get to work. All right, so hopefully you have your area model use of these for this multiplication problem. Hopefully it looks a little bit like this. Okay, so just double check your answer. Again, I took this 36 here and broke it up as 30 and 6, and then broke down the 72 as 70 and 2. And then within each individual box, I found the area of each one of these rectangles or four-sided shapes by multiplying 70 times 30 here, and then this same length here will be the same here. So we have 70 times 6, and then multiplied 2 times 30 and 2 times 6. I added up all 4 of my products here to get a total of 2,592, okay? Although there is a simpler way to do this, a standard algorithm, I still find this a very helpful way to do 3 by 2 multiplication, for example. You would just need to add an added column right here for the number in the hundreds place. And you can still break up the numbers by place value and still use this area model. Okay, so this is a very effective way. I feel like it's simpler also, and it also keeps practicing the area of what we need to do to find the area, which is multiply one side by the other to get the space inside. Okay, all right, great job with our warm-up. Let's get to our lesson now. All right, so page is 184, and at the top it says thinking about line symmetry, okay? So at the top you have 2 boxes. The first one at the top has a box labeled symmetrical figures, all right? And the other side has asymmetrical figures. Let's go ahead and study the diagram above, this one here, and this is gonna help us answer some of the questions below. It says circle the shapes below that have at least one line of symmetry. Use a colored pencil and a ruler to draw in the lines of symmetry on the shapes you circled. Well, first of all, we have to identify what is a line of symmetry. If I give you examples such as the leaf here, and I even folded it in half to show you that this has symmetry, what do you think a line of symmetry is? Also, looking at the shapes here, if you know that all of these shapes have symmetry, what can a line of symmetry be? Okay? So if we're looking at these shapes here, and even looking at this leaf, a line of symmetry is something that divides a figure. Let's take a look at this H, for example. If I put this ruler right in between the H, and this one kind of does a really good example because you can see the reflection. If I divided this figure in half, it would create identical shapes on both sides. You can kind of see it with the reflection there and the reflection there. But this shape, this H, has lines of symmetry there, down the middle, okay? Because if I divided this in half, it would create a mirror image on both sides. So if I put my ruler there, you can kind of see it, that on both sides of this H, it's the same. Whoops. Okay? But also the other line of symmetry would be right here going across, because the same thing happens to the shape. If I put my ruler there, along that line of symmetry, the same is on the top as is right on the bottom. So a shape like this H has two lines of symmetry, one going up and down that reflects both sides, and one going across that reflects both sides. Think of lines of symmetry as mirrors. I've always really liked that. And for those of you guys who are on TikTok right now, there's also a challenge going around where people use a mirror reflection right down the middle of their face. And you can kind of see if a person's face is symmetrical. So think of the same thing here, okay? Let's look at this figure here, this triangle, for example. If I put my ruler down the middle there, that's a line of symmetry, right? Because it doesn't change the shape on either side. But I can do the same thing if I intersect it or I cut it right down the middle of each one of the angles. So if I take my ruler and put it right through that angle, it creates a line of symmetry. So this shape here actually has 3 lines of symmetry starting at each angle. Okay? Perfect. So we have our lines of symmetry. Those aren't perfect. I apologize about that. All right. So now knowing what a line of symmetry is, let's take a look at A1, or 1A, I should say. Let's look at the shapes that have symmetry. Okay. A lot of the ways that we can figure out too is if we have a manipulative, like a shape like this, usually if you can fold it in half, and you have the same shape on both sides, then that is a line of symmetry. So this one, this leaf, for example, we know has 1 line of symmetry. If we fold it the other way, it doesn't quite have a line of symmetry because I can see a little bit of the other side and it doesn't match up perfectly as it does when I fold it this way. On this side, you can't barely see any overlap, but with this one, you can. It doesn't create a perfect line of symmetry. So this one only has 1 line of symmetry going down the middle. So we could do that same thing with some of these shapes. If you still have your pattern blocks, and I know a lot of us don't, but if you do, and even if you don't, you can always use these as references, okay? So for example, if I have my shape like that, or again, this triangle there, I can say, well, a triangle like this would have a line of symmetry because, as I showed you previously, if I fold it through these angles, through the corners, I would have the same shape on both sides, okay? But not all shapes will have multiple lines of symmetry. For example, this parallelogram that has parallel lines here, if I fold this in half this way, that creates a line of symmetry. So this will have 1 line of symmetry. But if I fold it down, it's not perfectly symmetrical because I can still see the 2 corners on each side. And so there's no full overlap, or there is overlap there, okay? So a good way to do it when they're on paper though, like this, is to just take your ruler and put it down centers of the shape and see if that creates a line of symmetry. So for example, this one, yes, that does have a line of symmetry. So I'm gonna circle that one. And then they want us to take a pencil and show the lines of symmetry. So I'm going to show for this one here. That's one line of symmetry. But if I'm looking at the shape, I can also bend it from here to here or put my ruler here. And notice that the same, that the same shape will show up on both sides. So I can place a second line of symmetry right down the middle this way as well, okay? So I want you to do that with all the shapes that you feel have lines of symmetry. Let's take a second one. Let's take a look at a second one together. For example, this arrow here, if I place my ruler right at both of those indentations, I would create a line of symmetry because you can see the same shape on both sides where the line is. So I'm going to place a line there on this one, and I know that this is one of the shapes of symmetry. I can double check if it has a second line, but of course we know that that is not going to have a line of symmetry there because if I put a line there, it doesn't quite mirror all the way over here. So that one will have that line of symmetry there, okay? So go ahead, there are, let me see, there's there's at least 2 more on there that have lines of symmetry. And I want you to draw them, okay? Part B says, draw 2 shapes of your own that have at least 1 line of symmetry. Use a different color pencil to draw in the lines of symmetry on each, okay? So the easy one would be something like a square. I'm going to keep using my ruler here to draw a square. Or we'll draw a rectangle, sure. Okay. So I'm going to draw my rectangle. Again, a rectangle is a 4-sided shape where 2 sides are the same and the other 2 sides are the same. And then my line of symmetry will go right through the middle. And I will draw another line of symmetry going this way here, okay? And you can get creative as long as there are sides of, or lines of symmetry, okay? So I want you to draw a second one here, okay? The next one is draw 2 shapes of your own that have no lines of symmetry. That should be pretty easy. That means that none of the sides have to match. So for example, I can draw a half triangle, half diamond, and get a shape like that. And if I try to put a line of symmetry there, that wouldn't work. If I put a line of symmetry there, that wouldn't work. So this one doesn't have any lines of symmetry. So what else can you come up with that won't have a line of symmetry? And now based on all of this information, now that you've seen what a line of symmetry does here, and even up here in our examples, okay? How would you define a line of symmetry in your own words? In your own words, how would you define a line of symmetry? All right, for the rest of your class, I want you to go to page 186. So this will be your assignment for today. And it says pattern block symmetries. For each shape below, decide whether a shape has a line of symmetry and draw in all of the lines of symmetry you can find. As I said earlier, if you're having a hard time figuring out if a shape has a line of symmetry, I would like to encourage you to trace these shapes on another piece of paper, cut them out, and then start folding these pieces to figure out if you can find a line of symmetry, okay? And where it would be. All of these shapes are your shapes that we did earlier, your pattern blocks, okay? So if you have them on paper, this would be really, really easy to do. All right, so you can take each one of your pattern blocks and fold them and see where you're folding them to create lines of symmetry. For example, I've just folded this in half. So I know that one of my lines of symmetry will be going right across, okay? So what else? Same thing with the square. The squares can be folded in half up and down to create a line of symmetry, side to side, but also corner to corner. Oh, look what shape that creates when you fold it corner to corner. Yeah, triangle, good. Okay? So if you're having trouble finding lines of symmetry, I would highly encourage you to trace these and cut them out and start folding and seeing where you can find some lines of symmetry. Again, your ruler is also a very good detector of lines of symmetry. If you can place your ruler, so here you can see it on these first two shapes. If you can place your ruler down the middle and you see that the shape is the same on both sides, you have found a line of symmetry. Of course, if we're looking at the first one and we're going across, we know that those shapes, if we fold that over, that won't line up, so that is not a line of symmetry. If we put it here down the middle, the top and the bottom don't quite match. Okay? Because remember, lines of symmetry are almost like mirrors. They should reflect the same thing on both sides. All right? So that is your assignment for today. All right, all you cool cats and kittens. That is all I have for you guys today. Thank you so much for tuning in for another lesson. Please make sure that you're asking me questions on Zoom or via email about any of the assignments. I am here to help. I'm here to teach. I'm here to geek out over geometry. So please, please, please make sure that you let me know. I look really silly with my hat like that. Anyways, I'm missing you guys. I hope that you're all staying healthy and safe. And I hope you guys have a great day. Bye.